Okay, so we're going to talk about cosecant and secant and cotangent functions today. Yeah, all three of them. So the thing about this one is that we're not going to delve deeply into them. They're very complex graphs, but I just want you to see them and be a little bit familiar with how they work. So the first graph we're going to talk about is the cosecant graph. Obviously, it's the inverse of the cosine, or of the sine graph. So when we talk about inverses, it's 1 over. So anywhere that sine is 0, which you'll look at this for a moment, the blue line, the blue dotted line, this isn't actually the sine, it's the sine wave, okay? So the cosecant is going to be the inverse of that. So any place where the sine wave would hit 0 is going to be undefined in cosecant because you cannot have a 0 in the denominator, right? So all of these are going to be asymptotes, okay? They're going to be undefined. And so that's just the one thing to realize, that multiples of pi will be asymptotes. Okay? Then if you'll notice here, just look at the graph really quick. This is kind of interesting how this happens. Where it hits 1, that's where it flips, right? That's the inverse, the reverse. So it will go, it will be going away from the graph. So if it's up here at 1, it's going to go up. If it's down at -1, it's going to go down. So all I want you to do is be able to recognize the graphs, that's it, okay? Be able to see them. If you were to see a graph like this, I would want you to be able to say, yes, this is a cosecant graph. And that's it, that's all I'm asking for. There are some transformations, but you're not actually going to have to draw them. All you have to do, and you can't graph these on a graphing calculator, well you could, but they're extremely difficult because of all the asymptotes. It doesn't show up right. So I may ask you, what would a transformation do? And all you have to do is talk about vertical shifts, stretches, and inverses and that kind of stuff. So you don't have to actually draw the picture. I wouldn't expect that of you. They're very complex. So moving on. So that's sine. Maybe. Okay, cotangent. Did I forget the secant one? I think I might have forgotten to put the secant in here. So here's cotangent. So cotangent, my screen recording thing, I don't know if you can see that, but it's messed up for me. Move this. Okay, so there's my cotangent graph. You'll notice the cotangent graph is simply inverted, okay? Again, the asymptotes stay the same place because 1 over cotangent is the same thing as 1 over tangent, and the graph is simply going the other direction. It still goes to the same, it does not go through the same y-intercept. It flips across the asymptotes basically. So, so you'll notice here the asymptotes are at 2 pi and -pi, and the graph is just inverted. That's all. Again, I'm not asking you to do anything. I just want you to be able to see a graph and say, oh, hey, that's tangent or that's cotangent. You have to be able to recognize them. In fact, I think on the test, I'm going to put just some graphs on there. You just have to tell me what function it is, especially with these ones. Like I said, I don't want you to go in depth. The homework is not going to be long tonight. I just want you to be able to recognize them and talk about those shifts. So I forgot to put a secant graph on here. I want you to be able to see that. So I will talk at you if you'll bear with me for a moment while I find the book. We are going to look directly on the book at this secant function. So give me a second. Pull up the book. What's really nice, just so that you know, all of these graphs can be found in your book. Chapter 7, Section 2. There's the cosecant. And I missed the secant function. All right, so let's go ahead and put this in here. So we can look at it bigger. All right, so okay, so here is secant function, obviously the inverse of the sine function, and okay, again, it cannot meet where the sine or where the cosine function crosses 0. It will be an asymptote. So you'll notice the asymptotes there. This looks really, really similar to the cosecant function. Okay. So the one thing that's going to be important is that you identify which one it is, whether it's cosecant or secant, and you identify that by the asymptotes. The asymptotes of of a secant function are going to go through the pi over 2's. The asymptotes of a cosecant function are going to go through the pi's. All right, and that's about it. So let's talk about just transformations really quick. So it's all I want you to do is to identify what they're doing. Okay, so this is basic transformations, which is what we talked about in class, which you should have done in Algebra 2 or integrated. Okay, you should already have these. And like I said, we reviewed in class, so we should just, all you have to do is identify. So number one here, what's going on? So it's a secant function. It's going to stretch vertically by 3 because the secant function is multiplied. So stretch vertically by 3. All right. And then the other thing that we have going on here is a minus 2. Okay, so minus 2, so we're going to move down 2. And that's all you have to do for these types of problems. Okay, you're going to identify you're just going to identify what the transformations are. That's it. So this one right here, 5 cotangent t minus 3. Okay, this one again, we're going to, the 5 on the outside says that we're going to stretch vertically. So we're going to do a vertical stretch by 5. And this in here, inside the parentheses, tells us which direction we're going to move right and left. Okay, since it is a minus, we're going to move right 3 units. So everything is going to be moved right 3 units. And that's all I expect you to have to say to me. Again, I don't expect you to graph these. I do expect you to recognize them, but these are complex graphs. So that's it for today.